The learning outcome of this video is finding sampling distribution of difference between two means.
A very good day. Today we are going to learn sampling distribution of difference between two means using Casio FX570 EX Classwiz Calculator. We have the population 1 with the mean mu1 variant from population 1, mean mu2 from population 2, and their variant for population 2. And then we have, from population 1, we have can take the sample, and we have got the mean sample number 1, mean sample from population 1. Then we will take the mean of the mean sample number 1, variant of mean sample from population 1. Then we have the mean of the mean sample from population 2, variant from the mean sample from population 2. And then we want to compare the sampling distribution of two samples which are selected from these two populations by finding the difference between these two means. And then to calculate the probability of difference between these two means, first we find the mean of the difference between these two mean sample, which is mean of difference between these two mean sample equal to the mu1 minus mu2. And then find the standard deviation of this difference between these two mean sample, which is sigma bar x1 minus bar x2 equal to the square root of sigma 1 squared divided by n1, which is number of sample from population 1, plus the variance from population 2 divided by number of sample from population 2. Write the normal distribution form and then calculate the probability using Z value, where the probability of the difference between these two mean sample greater than a value A will be equal to the probability of Z greater than A minus the mean of difference between two mean sample divided by the standard deviation of the difference between two mean sample. Example 1. We have a factory produce two types of bulbs A and B. The mean durability of bulb A is 850 hours. So mean the mu1 is actually 850, and then while the mean durability of bulb B is 820 hours, mu2 is 820. So step 1, find the mean of mean sample A deduct with mean sample B will be 850 minus 820, which is 30. Then given that the standard deviation of bulb A is 40 hours, bulb B is 60 hours. So step number 2, the standard deviation of the difference between mean sample A minus mean sample B will be the square root of standard deviation. The first sample A is 40, so 40 squared. Divided by number of sample A 35 here, and then plus standard deviation from bulb B, which is 60. So 60 squared, because this is a sigma squared, divided by number of sample from bulb B, which is 45. Then we get here. And then step number 3. So the sampling distribution for population A and B, mean the difference of the sampling between these two populations, satisfy normal distribution with the mean followed from step 1, which is 30, and the variant, which is 880 divided by 7. Step number 4, what we want to find the probability of a sample site 35 bulb A will have the mean durability at least 25 hours more than sample site 45 bulb B. So mean the probability of A minus B greater and equal to 25. Mean the mean sample, okay, A minus the mean sample B greater than equal to 25. Okay, and then this will be equal to the Z, and then 25 here we convert to Z score will be 25 minus, okay, the mean from step number 1 minus 30 divided by the standard deviation followed from step number 2. Then we'll get this value. Okay, and then we'll show you. Okay, we got actually two ways. Okay, we use Mono 7 for distribution, and then normal CD. Okay, normal CD. Okay, first of all, we follow this way. Okay, we change the original distribution into standard Z distribution. Standard Z distribution, where the mean will be 0, standard deviation will be 1. Okay, and then here Z greater than equal to negative 0.4459. Okay, the area is right hand side, so minimum is this value, maximum is a very large number. Okay, I will key in the original value, mean this value, which is 25 minus 30 divided by, okay, to key in exact, I will divide it by, okay, square root of 880 divided 7. Let's see, it's the same thing, negative 0.445. Okay, and then upper is a big number, 9 times 10 to the power of 99. Okay, if we convert to Z, okay, remember the standard Z distribution, standard deviation is 1, and then the mu will be 0. So we get 0.6722. Okay, this is used convert to Z distribution. Okay, if I don't want to convert to Z distribution, I will key in terms of the original distribution. Okay, and my lower will be 25. In my lower will be 25. Upper still the big number. Okay, sigma will be my result in step 2, which is I will key in square root 880 divided by 7. Okay, my mu will be result in step 1. So both leads to the same solution. So mean if you key into in terms of the original distribution, then okay, the sigma is result in step 2, the mu will be result in step 1. And this is a, okay, for greater than equal, this is a low value. You can see again, low value. Upper is a big number. Okay, and then this is a sigma, this will be the mu. If you convert in terms of Z, okay, you can either I will key in the original because afraid of the rounding error. I will key in my lower is bracket 25 minus 30, then close the bracket divided by, I will key in square root 880 divided by 7. Upper is the same thing, a big number. So if you key in terms of Z, remember that, okay, sigma is 1, mean mu will be 0. Both will lead to the same answer. So with this, thank you for your attentions.